Hello, welcome back to another video. In this video I'm going to look at the homework problem 6.1 number 46, and we are solving the system of equations and trying to figure out if it's independent, dependent, or inconsistent, I believe is what the instructions were. And if it is dependent, we want to write the solutions. Okay. So how we do this is we throw this in the matrix, right? So we put the coefficients in a matrix, 3, 2, -3, and then we put our things on the other side of the equal sign in the same matrix. Coefficient on R is 1, -1, -1, 1, 4, -1. Okay, so that's our augmented matrix, and then we do row reduction to get it to simplify, to get it into reduced row echelon form. And so first thing we want to do is get a 1 up here. And so to get a 1 up there, I'm going to, well, there's 1s below it, so I'm just going to switch a row. So we'll maybe switch row 1 and row 2. Those will switch around so that we get the 1 in the right spot. So my second row becomes the first row. And then the first row becomes the second row. Okay. And then our goal becomes to get rid of these two right here, to make those two be 0. So how I'm going to do that is to get rid of this 3, I'm going to do -3 times the first row and add it to the second row. I'm also going to cancel out the 1 down there, I'm going to do -1 times the first row and then add it to the third row. Okay. I'm going to do 2 at once just to save some space. Okay, so the first row isn't going to change. Okay, but then we were doing -3 times 1 is -3, plus 3 is 0, just like what we wanted. -3 times -1 is 3, plus 2 is 5. -3 times -1 is +3, plus -3 is 0. Okay. And then -3 times -5 is +15. Plus 10 is 25. Okay. And then we'll do negative row 1 plus row 3. So -1 plus 1 is 0. -1 is 1. Plus 4 is 5. -1 is +1 plus -1 is 0. And then -5 is +5 plus 20 is 25. Okay. Cool. So now what we want to do here is to get this in reduced row echelon form, we want to put a 1 right here. Okay. So right now it's a 5. So what I'm going to do is I'm going to times that entire row. I'm going to times it by 1/5. Okay. so that we get a 1 right there. So we've got 1, negative 1, negative 1, negative 5, and then our last row stays the same. Okay. So I'll times this all by 1/5, we get 0, times a fifth is still 0. 1/5 times 5 is 1, 0 times a fifth is 0, and then 25 times a fifth is 5. Okay. And we are getting very close. Now of the thing below the 1, so we're going to do negative 5 times row 2, and we're going to add it to row 3 to get rid of that 5 right there. And notice what happens here. Okay, so negative 5 times 1 is negative 5, plus 5 is 0. Negative 5 times 0 is 0, plus 0 is 0. Negative 5 times 5 is negative 25, plus 25 is 0. Okay, so notice we have a row of zeros we just created here. And so we're not going to have one solution here, because basically one of the equations, you can combine the two other equations to get the third equation in a way. Okay, so this will have infinitely many solutions. It will be dependent. Okay, my last step to get this in reduced row echelon form is my leading ones are here and here. Notice I can't get a leading one further down, right? Because this is all just zeros here. So what I need to do now is just get a 0 above the leading one right here, this position. So what I'm going to do is I'm going to add this row up to the first row. So we're going to do row 2, and we're going to add it up to row 1. Okay, so our final kind of matrix here in reduced row echelon form is these two stay the same. Okay, and then this one, when we do 1 plus negative 1, it's 0. 0 plus negative 1 is negative 1, and then 5 plus negative 5 is 0. Okay, so that's our matrix, and I'm running out of space, so let's take this away and see if I can find a blank one that we can do some more stuff with. Okay, so what we just ended up with, I'll rewrite it out so that you can see, because it's kind of down there at the bottom. Okay, so this was our matrix that we ended up as our reduced row echelon form. And so this is dependent because there's not a pivot, or sorry, there's not a leading one in every column and row. So we know this is going to be dependent, meaning that there's infinitely many solutions. Okay. But now we want to describe what those solutions are. Okay. And it's not all real numbers, because kind of like in the situation of two lines where they're the same line, it's all the points that are on the line, but it's not any possible point, right? It's just the points on the lines, right? On the line. If you take a point off the line, it's not going to be a solution. So you just need the points on the line. Okay, and so how you do this is you'll take your matrix in the reduced row echelon form and you'll turn that back into equations. Okay, so this 1 here corresponds to x, right? So that means 1 times x, and then this corresponds to y. We've got 0 y's, which, so we don't need any of those. And then minus a z is equal to 0. Okay. The second row means that the second column corresponds to y. Okay. So 1 times y plus 0 times z. Well, 0 times z is just 0, so we don't need to worry about that. That should equal 5. Okay. So really, our original system of equations can be simplified down to these two equations. Okay? Y always needs to equal 5, but as long as x and z satisfy this relationship, it's going to be a solution. Okay? And so then what we do is, and actually I guess the variables we used in this problem were r and s and t. So maybe I'm just going to use x, y, and z. But they, in the original problem, they used r, s, and t. So really this would be r, and then this would be t, and that would be, this is s. Okay, but I'm just going to use x, y, and z. It doesn't really matter. Okay. So to get our final solution, what you do is you take the variable that didn't have a leading 1 in the column, so there's no leading 1 in the third column, so z, and you're going to solve for every variable in terms of z. So you're going to move the z's over to the other side. So we get essentially, by adding z to both sides, we get x is z and y is still 5, right? And so essentially my solutions will be x needs to be z, that's my first coordinate. Y is going to be 5, and then z will just be z, right? It will be the same as z. Now the book will probably use different variables for this, or it could. You can use any variable for z that you want. You could use like q or t or whatever. Usually I think the book uses t, so I'll use t. Okay, so this would be the solution for any z you can put in here, and if you have the first and last coordinate are the same and then 5 in between them, it will be a solution of this system. Okay, so hopefully that kind of helps with this problem. I know it's maybe a little bit trickier than the ones where there is just one solution. Certainly dependent systems are a little bit harder to think about the solutions, but what you want to do is you just want to convert back to equations and then solve the equations for the variables in terms of the variables that you don't have a leading 1 for. Okay, so this we solved for x in terms of z. Y was already kind of solved for. We didn't even need any z's in there. Okay, so hopefully that's helpful. I will see you next time.